Good morning, everyone. I am Anjali Shukla, and I am honored to be your host for today's session. As we continue this incredible journey at this HH Launchpad Bootcamp series, it's great to see such an enthusiastic gathering of innovators, creators, and problem solvers. Yesterday, we had an insightful session led by esteemed speaker Debdyuti Roy Chowdhury. Since he will be continuing his session today, we will have the opportunity to dive even deeper into Fluvio, a power distributed data streaming platform. Moving forward, today's session will continue from where we left off, with Deb guiding us through in-depth discussions, practical demonstrations, and hands-on activities related to Fluvio. Expect to gain a deeper understanding of how to leverage this technology for real-time data processing challenges. Let's embrace this journey of innovation and collaboration.
All right, sorry, good to get started. All
Yeah.
right, awesome, perfect. Let's do this. Today, what we are gonna do is let me present now my entire screen. We are gonna have hopefully enough time to go through. I I've been spending the last hour or so trying to cut because I've got probably a lot, but whatever we don't get through, don't worry. Um, I will figure out a way to share recorded videos and other stuff so that you can go through different things. The just by way of reminder, we'll go to a single diagram which shows what this system is all about. We yesterday took some time to go through the basics of Fluvio, setting it up. You are running a cluster now, and you can create topics, produce and consume to and from topics. And we did see some examples of what we can do with it at least a level where we can see data coming in, processing that data through various services, and then consuming that data in the form of aggregate tables and then visualizing it as dashboards and so on. Now, what we want to do today is to go maybe take a step into this, double click a bit, and then slow it down also a bit, so that we can figure out. Yesterday there was a question at the end, or a comment. Can I show slowly how to build one of these projects from scratch? Now, in order to do that, there are a couple of recommendations, and this is something that will be reflected in the haphazards problem statement, or the track problem statement, if you will. Because if you think about this platform for data processing, there's a lot in there, right? You can actually look at core Fluvio and build with the client. You can build connectors. You can build data flows. You can build operators or smart module packages. And if you go into this documentation, for anyone who has explored it, there's a section for developers, and it talks about how you can build, using the developer tooling, your own modules, your own connectors, and so on. Now, these are just nice options, if you will, for you to build a flexible system and a flexible project, which is scalable, reliable, and so on. But in the context of a limited hackathon, it makes sense to limit the scope of how much you want to do, right? Because you have limited time. You don't want to go into the weeds of every corner of this product, which may make your project way too complicated. So in that spirit, what we are going to do is we're going to focus all of our hackathon specific problem statement and track to defining data flows. Now, defining data flows will actually assume that you have some form of connector, and it may or may not require smart modules, but we would try to deliberately avoid developing new connectors or smart modules. What that means is we would want to use clients, and we would want to use, hold on one second, please. I need to take 1 second. Sorry about that. Okay, where was I? So yeah, we will actually constrain our efforts to building data flows, and we would leverage existing smart modules and uh, connector packages that we already have. Now, I just want to let you know, because some of you actually tried to use this. I will coordinate with the hack hazards organizers and get a list of all the people who end up participating in the InfinyOn track, because I need to create uh, accounts for all of you to be able to access ideally a single cluster. So I'll figure out how to share that information before the hackathon. Obviously, we've got a couple of weeks there, but this is just logistics information. So what I will ask of you is, this is the link to the Fluvio community repository, and I'll post that in the chat. Hopefully, I'm an organizer here and I have access to the chat. Yeah, I see. That's good. So I would say just follow this page, because all of the code base for the modules that we're going to use or not are all available here. So the source code, I can hear a little bit of background. I don't know if someone is unmuted. Can you please mute yourself? So all of the things that we would end up using and more, most of this stuff, the source code of it is here. So I would say follow the community page, and we have a bunch of connectors in here. And whatever we don't have, I will make sure that I'll point the repository there. Okay, so just make sure that you have this link handy. The other thing is, at the end of last session, there were some people who joined our Discord, and I got some questions on this. So that's why I'm just sharing this information before anything else happens. So inside of our Discord, let me see. I actually will post the invite again for anyone who doesn't have it. Inside of our Discord, there's a specific channel called InfinyOn Hack Hazards. Okay, and that channel, if you go into that channel, it's a forum style channel where you would be able to create posts. So I have a post right at the top where I will update all of the information regarding the track, and all the resources that you would need to follow, including the link that I just shared with you. I will put that in there, so that that's like one thread where you have everything that you need. And in here, you can come and actually create a post if you're facing some kind of issue during the hackathon. If you have a question, if you have a project related ideation, whatever it may be, you can come and share that, and that's how we will communicate during the hackathon. I'm just letting you know, because when you have hundreds of people or thousands of people commenting in different channels, it becomes a little difficult to track. So just make sure that you go to the right channel, InfinyOn Hack Hazards, and ask any questions that you may have. So I'll just post that in the chat as well. No action required. Just keep the invite handy, and you can join during the hackathon. That invite should not expire. And if anyone is facing any issues, we can figure that out. Okay, so those things being said, what we want to do here is we're going to do two things, or three things rather. We're going to look at a simple example, word count, and I will implement the example in stateful data flow from scratch. Word count is a very simple algorithm. Basically applies a couple of functions. One function to tokenize, basically chop out words from sentences and then group them and then count them, and we would do it over time window, so we can see most of the functionality of building a data processor, if you will, which has a set of operations. Then yesterday when we were talking, we were looking at the Helsinki transit system and the data that comes in from that source. So I will set up a system which will use that data, and then we will apply some processing to get some average speed going and querying and stuff like that. And I will want to do a simple example of using callouts to the OpenAI API. and eh, do basic summarization and things like that so that you can see. My hope is that these three examples will give you at least enough of a foundation, and then you'd be able to use these three examples and the other examples in the repository that I've already shared with you to practice, right? To basically get a familiarity with the system, and then when you are trying to build stuff, you can extend it, right? And then we will have time for Q&A and stuff like that. This is the plan for today, just so you're aware. Before we dive into this, I want to actually talk to you a little bit about um, each of these data flows, right? We have we have already looked at what we need to set them up. So I want to talk to you about a couple of different ways in which this can be done, right? And why you would need an account just to be able to access the hub on InfinyOn Cloud. And to anyone who has posted on the chat saying you are not able to download, you're getting an error downloading Smart Module, or you're getting an error downloading a connector. If you are, that just might be like our security settings not allowing you to access without a valid login. So don't worry about it. When you say you have a connector to bring data in, let's say you have a Smart Module to transform this data. These are packages that you can download. Now, if you did not download those packages, the other way of building it when we are doing as a developer and we're working self-hosted is using the developer tooling, right? So you can compile and build those packages, and you can work with them. But obviously, it's a little more time consuming, right? So we want to avoid that. So I'll just show you an example. If you were using a connector and you were essentially running that connector, this is what we did. And this is what we do in most of my examples, because I'm running everything self-hosted on my system. I have the connector packages, and I basically use CDK, or Connector Development Kit, to run this stuff. Similarly, Smart Modules, I can download it from Hub if I have an InfinyOn account. If I don't, I can use Smart Module Dev Kit, or SMDK, which is for developer section. And I can use SMDK load to load the Smart Module into a cluster from the source code, right? So there are two ways of doing this. Take a prepackaged binary and load it. This is the way that I would want all of us to use it during the hackathon. And for that, I will need a list of all the participants who will participate in this track, so that I can create InfinyOn cloud accounts for you. And then I'll give you on your email tokens for you to register. And once you've registered, you will see one dedicated cluster, which will allow you just the access that you need to be able to download these things. If you're doing self-hosted, however, this is an FYI. As a developer, how you would use it when you're building any of these stuff is using CDK and SMDK. Okay. So I think that's all the logistical information I wanted to cover. So let's dive into the fun stuff, if we may. Let's see. This is supposed to be the word counter. Okay, so we are going to start with this. There is nothing in this directory right now. So you asked me to show you how to build this stuff from scratch. So that's exactly what we are going to do today. And the word counter example is where we start. Okay, so that data flow is a very, very simple one. I will first show you what data we are going to work on, the demo data that we have. And then I will share with you basic idea of this outline of how to build this. And then, I'll type the code up, copy paste some, and then we'll build and we will run. That's going to be the flow. Now I'm going to pause for a second because I heard a few blips in my headphone over the last, let's say, 5 minutes or so while I was speaking. So let me pause and ask before I start, who has questions? Do you have any questions, any of you? Did anyone raise your hand? I can't see that right now. I didn't actively look at the participant list. So does anyone have their hand raised right now? Anyone have any questions? If not, I'm looking at you now. If you can give me thumbs up. I'm looking at the other screen. if I'm good to start, I'll just get going. Okay, thanks, Akshay, Ashutosh, Om, Kanishk. Okay, great. Perfect. Okay, so let's do it this way. I'm just going to hit a demo data endpoint, demodata.infineon.com. This is just like a simple server that's running. And we have this data that is just sending quotes of different people. So I can just curl hit that endpoint, and you can see what this looks like. So it's basically a simple stream of data, and you see there is a quote. It's very simple JSON, and there is some text, which is a sentence, right? So for example, we cannot solve our problems with the same thinking we used when we created them. This is a neat quote by Albert Einstein. So, it's a very simple API that is sending this data. And as you can see, I can hit it again. It's just sending a quote a second, right? Or something like that, or maybe 2 quotes a second. I don't know what is the speed, but probably 1 quote a second. So we have this endpoint that we're going to work with, and I'm going to basically write a connector to get this. Now, just for the sake of ease of use, I created a directory called connector packages and downloaded all of these in here. For everyone who is excited and not want to wait until the hackathon to try these things, you can use the connector packages in here. And I'm going to give you a link to this Git repository. It's in my personal GitHub, and you can clone it and you can play around with it. So inside a word counter, let me create a directory just for organization called connector. This is where we will have the connector configuration, and we will create a connector configuration file, which will be a YAML file. Okay, so one thing to understand with Fluvio and InfinyOn is that pretty much every configuration, whether you're talking about connector, smart module, data flow, these are all YAML. And then the code inside of it could be Rust, SQL, depending on whatever you're doing. And we use the YAML to define the configuration of the system. And then we also use the YAML to code generate and apply various logic and stuff like that. So this will be, let's call it, let's see, QUOTES, quotes, connector dot YAML. And basically, this YAML will, the idea is that we are going to use the HTTP source connector. Okay, so I'm going to say CDK hub list, right? And this is the part that might not work for you right now if you try it without an ID. So don't worry, we will set that up. It'll be fixed. So for now, you're just going to go grab the HTTP source connector from here. But I'm just going to download, and I'm going to give you the folder, and you can get cranking. So we're going to use the HTTP source 0.4.3. So ideally, when I'm building a project, what I'm going to do is I'm going to have the connector. And I typically have these iPackage files as a git ignore, so that it doesn't upload it to the repository. But in this case, I'm not doing it just so that I can upload it and give it to you, basically. Okay, so clear that. Oh, gee, what did I do? Sorry. Clear. Okay, so CDK, actually, CD connector packages. I can go CD dot slash. Go to that directory, basically. And then CDK hub download the HTTP source connector that we're going to need. Okay, so what that did is downloaded that connector in that package. Now I'm going to have to put that configuration file. So this configuration file, it basically is going to be this YAML. So starts with API version. And I should have like a Copilot code complete on this here, but I don't have it. So we'll work with what we got. So the API version, we have 2. So I mean, right now 0.2 is the highest version of the API that we are using. There are some connectors using the API version 0.1, but that's fine. So the metadata, you've got version is the file that we've downloaded. That's this version right here. 0.4.3. Name your connector. Let's just call it quotes connector. I just named it quotes connector, right? This is what the name would be of the connector that is running. So you name it based on what functionality and how you want to organize it. There are people who might connect to the same services but have multiple instances of connector per customer group, user group, and stuff like that. So you could sometimes have like a pattern where you number them. So say quotes connector. Then the next thing I need to say type, and the type is this HTTP source. And then this data will flow into a topic. So let's call that topic. We need some metadata here, topic. We put a version to that topic. 01. And then put a name. This is the name of the topic. And we call that topic sentence. Okay. So that's so far so good. We just declared some metadata and defined the connector using this package. We've put the configuration here. Now we would go back to that meta level and go into the details of the HTTP endpoint that we are going to hit. Right. So we are using HTTP. We're hitting an endpoint. Let me capture that endpoint real quick. Okay, so it's the same one that I was looking at here. Yep, so that's that. Now with HTTP, you have a method. That's get stream true. So this is a streaming connector. You could have polling, streaming, and then other than that, you have WebSockets and webhook, right? So true delimiter. Delimited by new line. So far, this will get the data from the source. Now, if you want to do the transform, this is where you put in the smart module. So you can say transforms. Let me just add a little bit of space here. So transforms. Uses. So what is the transform using? This is where it uses the smart module. I gotta copy that smart module here. So let's see. Fluvio hub SM list. That'll give me the different smart modules. I want to use this Jolt one. Well, we started actually using the JQ1 or Jack is what we call it now for JSON transforms. So I'll show you an example of that, but we'll just use the Jolt one for this one now. Uses Jolt. So you just plop that in. And just to make sure I have everything going, I'm just going to say Fluvio cluster status. So you know that this is running the local cluster, 2 topics, is all good. I think I did download the smart module yesterday, but just to be safe, Fluvio hub SM list, just copy that and say Fluvio hub SM download. All right. Okay, so we're good. We'll use that, and then we'll provide the criteria. So you need to say with. Sounded like someone raised their hand. Just give me a second. I've got 2 more lines, and then we can ask or answer any question. Operation shift spec quotes. So basically what I'm saying here is that we will have, as we saw in the data, and this is why a simple example helps get started here. So uh, as we did in the as we see in the demo data endpoint, what I'm saying here is that this payload has two keys right here, right? And the shift operation basically looks within the payload to find a match for the key that I'm declaring. So what I'm saying here is that use the Jolt Smart module, look at the payload here, and get the values for the code. So what I'm going to get as the output into the topic is for every record, I'll get the code, right? Does someone have a hand raised, or does anyone have a question? I think that's, yeah, I do see someone's hand raised here. Yeah, please unmute yourself. You can ask your question if you want. No? Okay.
So unmuting was disabled. So just a question I was following along. So when I tried to download the Fluvio Hub SM model, the Jolt one, I was unable to do it. I got
Yeah, so you're getting, this is, I mean, maybe you join a little bit later or whatever. So you're getting a 500 or something, right?
yeah, socket connection refused.
Yeah. So the reason why you're getting is because we it's our security, so it's tightened. I can reproduce the error. Yesterday someone had posted it as well. So
Yeah, that was me only.
okay, gotcha. So we'll fix that. So in order to do that, what we'll have to do is all the list of the participants who will participate, I'll have to create cloud accounts for you, because what we were doing before is we were allowing the hub commands like this Fluvio hub SM command here um, to run without the org. So if you notice when I run this, right, it is using an org address. So it was previously not tied to an org, so it was not tied to an auth, right? What this org thing is over here is, you see, this thing right here, organization, right? So I've got like a few orgs. So this is tied to the account. We actually would earlier allow you to run these hub commands because all the hub packages are basically these packages right here. We allowed people to run it without authentication, but right now it's tied to the org, so you require an account to be able to do it. So it's not an issue, it's working as designed, but for you to be able to use it, we will create accounts for you. What I'll do is I'll have a list from the organizers of all the people participating, and I'll create an account on InfinyOn Cloud and give you a cluster space and a token. Basically, everyone who participates in the track, you'll be able to reproduce it. Until then, I can download the connector packages separately, and anything without the smart module, and there are some examples I'll share without smart modules, you'll
I
be able
was
to do.
I was able to download the connector packages.
Yeah, that's because you're using the CDK thing,
Yeah.
right? CDK connector dev kit, right? So it will download the connector packages. The workaround is to essentially use the SMDK thing. So this Jolt, right?
Hmm.
Okay, since you asked this question, let me give you the answer.
That I
Um,
guess transforms sentences to JSON file, right? Something like that.
it actually plucks out from the JSON the specific piece that you need. So let me share with you what Jolt is actually for anyone who needs to. I think it's initially was created by Bazaar Voice. It's actually, we implemented the Rust version of it. This is actually a pretty old project. Okay, so you can see the screen. This is Jolt. Um, there is their own documentation. This is basically domain specific language which allows you to apply various JSON transformations, right? It's jQuery like, but Jack is different, jQuery is different, Jolt is different, but it's just JSON to JSON transformation.
Okay.
Now, in you can still use the smart module, but if you wanted to use the smart module, it actually adds a couple of extra steps for you. Like you'll have to just use not the package, but you have to use the actual repository. So let me show you this. if you come to Fluvio GitHub, this is the Fluvio official GitHub, which I had shared yesterday, right? So
Yes.
inside InfinyOn's repository, all of these things are actually public, the code base for it, right? So if you click on Jolt, you can see this is basically our smart module implementation, right? So if you clone this repository, if you clone this repository, and then you go into um, this smart module for developers, build and test and load to cluster. Basically, you can say smdk load in that directory, and it will load, it will build the package and it will load to the cluster. Now that adds a couple of steps, downloading that repository and loading the cluster. This download is easier, and this is what I mentioned in the beginning of the call. I will just get a list of all of your all of your email addresses, right, of the participants of the track, and I'll give you InfinyOn Cloud accounts so that you can download the binary and use it, right?
Okay, sir.
Um, right? You should be able to do it still. You just right now you'll not be able to follow along with the cloud download way, and that's just working by design because we tightened our security.
Okay.
Okay. All right. Okay. Perfect. So sorry about that, but hopefully this answers everyone what this is happening, um, what has actually happened here. So okay, this actually completes the connector, the quotes connector. Okay, so it's writing data to sentence, it's getting data from the code, and what it is doing is you give it a payload, and just remember this pattern because this is the same thing that uh, is useful in the Helsinki transit as well. In this case, it's just going to search for this key and get the values in there. So if I were to launch this connector, clear, we are in this connector repository, right? So launch the connector locally. We say cdk deploy start. Actually, I'm going to do it on the other terminal because it's just a little bit better with the autocomplete and stuff like that. So cd into the word counter and the connector, right? And I can say cdk deploy start, and just this is the connector package. And the configuration is quotes connector YAML. Okay, so that starts a connector, right? So you can say cdk deploy list, and you can see this sentence connector running. I can actually stop the trips connector from yesterday, deploy, and this at least shows you how to shut down. cdk deploy shutdown and pass the name, and that will shut down this trips one. So now I've got the sentence connector. So we can say Fluvio cluster status. Now we got 3 topics because I cleaned up the cars one. Fluvio topic list will show you that we have got the sentence topic now, right? And I can say Fluvio consume. And so PU tips will consume sentence. And you can see that we are getting the quotes data coming in. All right, so this sets up the connector. Now, hopefully, this is the pattern, right? Like we will do it again with the MQTT source, and you will see like this is exactly the way in which it works every time. So we got the data coming in. Now let's build the stateful data flow. Okay, so you got the word counter, we got the connector. I'll come to word counter, and I'm going to create a directory called data flow. Okay. The connector is running, and you can see there's a log. I should probably git ignore that log file. But that's fine. So now the idea is that for data flow, and this is just like organization, I could just have the data flow. Actually, you know what? That's what I'll do. Apologies for that. I'll just create a file here called dataflow.yaml. And this is for building out the stateful data flow um, that will process this data. Okay. Um, so word count, and let's see. So the data flow.yaml now, what it will do is it will process this data, right? So it's, as you can see, is just getting string, right? And it's going to apply this operation where it will tokenize or get every word, chop it up by space, and then it's going to group the same words that it sees over a period of time. Then it'll aggregate them, and it will keep on counting them. And then over a time window, it will say, okay, this is the amount of words that we see. And then it keeps on repeating that process over and over again as it runs continuously. So that's the goal for this. Same thing here, SDF also, everything basically starts with API version. This is basic. CI/CD DevOps practices, make sure that everything is versioned, and you know what is actually running in production versus what is running in development environment. You're going to all use the same thing. You will probably not change it in the context of your hack, but in the real world, when you're writing stuff, you want to version them. And as I'm writing the metadata, you can see this. After the API version, the structure is pretty consistent. You give it a name, right? So let's call this one word counter. And we'll have a version for this data flow. And you just apply basic versioning practices here. And there is a namespace. So the namespace is like tied to your org, so you can apply whatever. In this case, this is example. This is how you separate various environments where different data flows are running, and teams and so on. Okay, now that part, you can hide that. Just going to talk about the config. We've seen some of this. So these are things that will be part of every data flow file. You will not be like manually typing and developing it in the world where you can AI generate code generate, and or even before that world, maybe copy paste with the examples that we have, right? So the configuration has the format of the data. So you provide something called converter, and this thing is called serializer, deserializer. You're just specifying what data format you're getting in the config, and we're going to look at JSON, and that's pretty much that. And then you have to specify the consumer. This is when you're processing this data, you have to define what is the starting offset. So default starting offset, and it basically starts at 0, value 0. And position, as it maintains this offset, like it tracks how much it has processed. If it fails, it will start from the last process record. So that's the configuration. Okay. And this is going to be pretty much consistent for every file, unless you're like working with some other format of data. You will change this, but this stuff doesn't normally change a whole lot, right? Now, as we saw yesterday, we define the types, right? So I'm just gonna for this is gonna have types. We've got sentences or sentence, and as we see, sentences of type string. So this actually, what you're seeing, this type is what you call, these are like domain specific language. So these are basically types that we define to parse or process the data that we are getting, right? And when we are getting single records of string as each quote, then we just gonna call that a string. Everything else basically forms objects, and within objects you could have strings and numbers and stuff like that. So that's the input sentence. And then we can do word count. And that will be an object because it'll have a few things in there. And then the object will have properties. And properties have two. In this case, we just have word and count. Word type is string. Oops. If you observe a typo or something, just let me know. I think it's okay right now. So count type U32. Unsigned integer 32-bit. This is what we have for the count. Sentence word count. And I think that's 2. We'll have another type because we are going to look at it in time windows. So it's the top words. We find the most frequent words. And that top words would be a type list. And it will have items type. I should be copying that here. Word count. Now, again, like I said, most often you're not going to be hand defining some of these things. You'd probably take assistance of a copilot or whatever, but this is the structure, this is the format, right? I mean, it would be as long or as short as the data that you're processing, and there are no two ways about it, right? Your schema is your schema. This is a fairly simple one that we work with. So we got word count, and that's your type. So I can collapse these. So there's sentence, there's word count, there's top words, and there is oops, sorry. I thought I just okay. So that will collapse into types, and then I've got topics, as we saw yesterday. So topics, every type that you describe would essentially map to some topics, right? So we got a sentence, topic, sentence, and the name of that topic. And basically here you can see you can do some aliasing here. I'm just using the same thing, but the data is coming into a topic called sentence, right? Now you could alias it, right? You could say this is input topic and the name of that input topic is sentence or something like that, but just the name would have to be the name of the topic, which is storing the data on the cluster, right? So it's storing that data in the sentence topic, and then we say schema value type string converter. Now this will be just like the actual data inside each sentence, and you just like string. There is no converter. There is just like binary, right? So you say raw. Binary is raw. And then we did a type here called top words. So you can say most used words, maybe. And this will be a topic that we will produce output. Schema. Now you see how once you build this, essentially is just the same pattern for each piece. It's just like, okay, here is the name, here is the alias, here's the schema, here's the value of it, here's a converter. So this is same pattern you're using to describe all of the different data sources, right? Once you do 3 or 4, you're like, okay, this is the same thing. You're repeating, so you can copy paste and simplify some of these things, but um, the pattern is what you need to learn to be able to um, to use this, right? So here, schema value. Actually, now in this case, most used words, the schema value would be this, because we are going to compute that. We're just going to pick from it, right? So you're going to get the input as sentence strings, and we're going to produce most used words. This will be the output, and the value of that is the type top words that we define that object there, or list. Now, if you look at this relationship, so most used words is referencing the type top words over here, which is referencing the type object. So this is a list of objects, and the objects is essentially word count, right? So it's the relationship. I mean, you can see the entity relationship right there, right? And anything in data, when you're looking at schemas, that's kind of what matters, right? And this is how you go about working on it, right? So we've got the topics here, sentence, most used words. That's good. Now what you need is to define the services, which will process the data and get you to that result. Okay, let's see. So services, services, services. So services is what runs operations, right? You could have a series of operations, and those operations will apply various degrees of transformation. In this case, I think we have a single service. Yeah, let me just check. Yeah. So in this case, we have a single service. So let's say word count service. Okay. And I need to tab that, indent it. So you got that going here. So now every service, and this is the pattern of the service, every service has a source topic, source data. And most cases, if it's producing an output or intermediate data, it would have a same topic. So you can say sources, and the sources is of type topic. And we're going to take it from the sentence topic. If you didn't guess it, ID is sentence, right? So we define this topic here, right? This topic sentence as the ID is pulling from the name sentence, right? And we've defined the type. So all of this is 1:1:1. This is what we are pulling the data from. That's the source data. Okay. Let's see. So sources, type, ID, sentences. Okay, that's good. Now, once you have defined the input, it has to be then sources. In that service, you would have states. So now state is when we're doing stateful data processing, right? State could be two types. It's like you define keyed states to keep track of. Whenever you're aggregating, grouping and stuff like that, you'd have keyed states. And whenever you're doing temporal processing over time windows, you will have timestamps or watermarks. You can read up on this just to give you a quick plug on the documentation if you're thinking, I mean, I'm going as slow as I can, but if this is still really fast, I would point you to the SDF concepts, and you can see state right here. And there are examples, right? So all of this is there. So, this is the overall of the data flow. What are the services? What is the architecture of services? What are the operators that we use inside of them? What are the types, the primitive types? And all of the things that we are using are described over here. The validation logic that applies to schema, and here is the state, and other stuff that we're going to do, right? So this is where the documentation is. Anytime you're trying to figure out what do I mean by that, well, that's the dictionary or that's the documentation. Just refer to that, and that would be good. Okay, so for defining the states here, we are going to count these words. So we're going to have to keep a count per word. Okay. Type for that, we have defined. That's a keyed state. Properties. And you can see again, we are replicating the same pattern. Everything has, and this is the thing, like people, once you get the hang of it, this is very, very simple. I mean, it's as simple as it gets in this paradigm anyways, right? You're really operating at a level where it's declarative, the syntax, and you just like defining the structure of how you're working with the data and how things flow. So type string, that's the key. The value that we are getting here is when we are storing state, we would mostly either use timestamps or arrow rows. So arrow row is, like I mentioned, it's, let me actually show you that value. I should say type arrow row. It's like the same exact pattern. For anyone that just does not know what that is, arrow. Okay, so this is a in-memory columnar format for fast data interchange and in-memory analytics. So it's like a library which is for fast data processing. So we are using that for in-memory computation. So that's why the value is of that type. So this is all you essentially do to declare that aspect of the system. And then value, I think we need to say properties here. So type, properties. Okay, properties. And here, the reason why is that because you're going to keep count of something, right? Count type E32. So that's the thing that will basically create the memory object that will keep track of the state, and it will keep on counting, and it will keep on processing the records and then giving you the response that you need, right? That's that part here, states. Let's see now. We gotta go after that. Okay, now we've declared the sources and we declared the states. We have to now go to transforms. And this is where we apply the transformation operators. Right? So once we have declared the states, now notice this keyword transforms is something that we used also in the connector using smart modules. So in a sense, there is a similarity between this transforms using a smart module and this transforms where you're going to use what we call here an operator. So an operator is just, you could say loosely, a smarter smart module. It's more functional and it's stateful, and you can extend it. But these things are basically WebAssembly based data transformation. So here, when we say transforms, we're always going to have a series of operators, and the operators are going to use some primitive, as you can see, flat map. Reference that in the documentation here. You can go to operators and you can see map, filter map, flat map, assign timestamp, all these things we have seen in a diagram. And you can go into each one of these, and it actually gives you examples of those as well. Okay. So you're going to use the flat map one here. And so an operator, then once you call that primitive flat map, now it's just a matter of like, how do you want to run this flat map, right? So you have to give that function. And this, as I mentioned, was the inline way of doing it. So just keep that in mind. Just some type of function, split underscore sentence, or actually say splits sequence. because I've used the word sentence a bunch. So let me just copy the logic here for that function. I've been typing for a little while. Okay, so what we are doing, if you look at this function, is it's going to take the input a sentence. We've already declared it as a type string, and we produce result in the form of a vector. And the function basically applies this thing. It's going to split the sentence by white space. It's going to map the words based on characters. It's going to apply some basic filters to see if there is alphanumeric patterns and so on, character patterns. And then once it has done that, it will find tokens. It's not the same as the tokens that you think about in AI, but similar, right? So it'll basically get words, and then it's going to apply more filters to make sure that you get a list of words or a bag of words. So ultimately runs the collect. So it's basically running what we need to do to get the sentence chopped up and split up into parts. Okay, so that's the function that it'll run. Now we want to run this over time. So we have to declare in the transforms, we've got window, tumbling. So this is the type of window operation we're doing, and duration. And let's call that like 10 seconds. Okay, so every 10 seconds, or maybe we can say 30 seconds, so it's just a little bit more, it will run this operation. Okay. Now, in order to do that, now all of a sudden, as soon as I did tumbling window, it requires you to do the assign timestamp. And there, I'm going to copy a function to run. So now you see it runs another function here. So it assigns event timestamp. And it's just going to assign, in this case, a timestamp, because the payload doesn't have a timestamp, right? So it's just going to assign a timestamp. Then we're going to partition, because we got these groups. We're going to put these groups of words together. Again, I'll keep on plugging it so that you can get these, right? Operators. So you can see assign timestamp right here, right? Assign key, update state, plug. All of these are examples in here, and you can take a look at that, right? For help. Actually, I can probably just copy that, because this is what we are gonna do, I think. Let me just copy that and I'll update it from there. Just give me a second. So partition. That's why I don't like this copy. Sorry, don't bother. Just indentation is important, so it just doesn't really doesn't really help me if it doesn't indent properly. So a good partition. Then we do assign key, and in that we use the keys to run this function assign word key, where we are going to map the words with each other. We're going to say each word that are similar to each other will basically, each word that are identical to each other will be a key, and then we can use that to match the other words that we see, which matches that, and we increase the count. So that's the increment here, the update state, where we run the function increment word count. So you take that state, start at 0, and basically every time you get another word, you add the count and you update it, right? So that's that piece here. Okay, what else do we have here? Partition, update state, and yeah, okay, so we've done all of this. Now it's just a matter of like pushing the data. So partition flush. So flush is here, right? So window tumbling partition, okay, here. So flush is this one right here. I won't copy from here because it's gonna mess up my indentation. But basically, this is what we're gonna do. We're gonna compute the most used words, result top words, and then initialize word count as count per word, and then we get the top three. And we can change this. So this is where we can probably look at this SQL statement here. So it's a top three word count SQL select plat from count per word, order by count, descending limit 3. Let rows top 3 rows, columns top 3 schema, and then basically we put that into a neat format, put the output, match the columns, put into key value, and put those records as word and count. It becomes a tabular representation. If there's an error, it will return an error. If there's not an error, it will produce that output top words. So I'm gonna put the function of flush here. Let's see. Okay, there you go. So run, compute most used words. Okay, that's good. So that's the same exact thing. And then we will just produce. So what we have done so far is got the state inside the transforms. We got the flat map. Then we declared a window. And inside of that, we've got this tumbling window, timestamp assignment, partition, update state, and flush. The only thing that is remaining now is to write that data out to consume, to be consumed rather. To let's see where we have the services, word count, where the sources. Okay, so you got the source at this level. We gotta have the source. I think it's here. Okay, so sinks. That's where the data will go. So it's gonna go to a topic called most used words, and that's pretty much it, right? So this is the overall data flow. Word count service, sources, states, transforms, window, and sinks. All right, I think that this is all looking good so far for me. I should just clean up a little bit. Okay, so given that this now works, the flow is quite simple. Just save that data flow YAML file. And what you want to do is to run this in an ephemeral worker. So let's see, we are in the connector directory here, I think. Okay, so go back one level. You want to be in the directory where we have the data flow.yaml. Give me a second. I'll answer any questions in a second. And then what we want to do is from that directory, you will notice what happens. This is what it is. It is going to now build the project. So SDF run, and I'll call the UI flag here. Okay, I think I messed up. Did not find. Okay, I missed a hyphen 48 line, column 7. Let's see, 48, 46, 47, 48. Oh, I think type topic, ID sentence. Is that it? Maybe indentation is important here. Let's see. Okay. Invalid type string top words expected structs already config. Okay, let me see. What else did I do? Top words, type list, item word count. Okay, let me see. Control F. Top words. Okay, so there's top words, list word count, schema, most used words, top words. most used words. Okay, I kind of made a miss of that here. I think. Let's see. Most used words name. Hmm. Okay, I think I messed up here. Type. Probably. That's it. Okay, perfect. Couple errors, fixed, no biggie. Um, and this is typically when you're doing the YAML, this is what you have to look out for. This is as real as it gets in the dev experience. It's much easier with like code generated stuff and Copilot stuff. These errors are typically fairly avoidable, and if you're doing copy paste, you probably stick to the schema and the structure there. Yeah, just need to be aware of the indentation and the alignment of stuff. Okay, so I think it's built it now, and this is the flow of what it builds. Now, obviously, since we have data flowing, you notice this is how it kind of works, right? It is counting the data and it's producing. This is the ongoing window, right? So you can see how the word is being counted based on the codes that is coming in, and every 30 seconds it kind of finishes and starts with the timestamp value here. Yeah, so now it started a new window. Excuse me. So you can see this flow, source, sync. What are these functions and how they're kind of going about their business. I can actually say show state here. Remember, we have all of the observability right here. So these are the request part processing piece, and then this is the service. The metrics for the sentences that we are getting, the topic offset, all of that. And this is something that we didn't see yesterday. So I can say SQL. And this is actually like a interpreted columnar SQL inside the pattern. So let's say if you're building a project, and this is something that I would reckon that you use. So remember in the data flow, where is my VS Code? In the data flow here, you have a SQL statement that actually is used in producing your output, right? And you can actually play around with this in the interpreted SQL here. And this is basically running columnar form of SQL on live data, right? So this is what it is producing. This is the last materialized window, which you can see in the topic. So you can say show tables, and that will say this is the count per word, and you can probably run that SQL here and change the limit to maybe 5, right? And that will update your topic. Now, this is fairly simple because there is just like 2 columns here, right? So you cannot do other than just like ascending, descending, limit, and this kind of thing. But imagine when you have multiple columns, as we saw in the example with New York Transit yesterday, you can join various columns, and that would be quite involved. So I'll actually run that data flow and show you some interesting queries to run as well. So the idea would be when you're building a data flow and you join different data sources and bring it in, you would want to set up the basic data flow outline by setting up the types in the schema objects, setting up the topics, and setting up the basic service. So first service, what you want to do is you want to set up the keyed state. Even if you don't do tumbling windows, you can do some window operation, that's fine. So you set up the keyed state, you set up the window-based materialization so that you get a subset or a snapshot of that aggregated data. and then you can come to the SQL interpreter here inside SDF, and then write various queries to slice and dice the data in different ways. Once you slice and dice the data in a way you want to, you can take that query, create an operation to apply that query, right? The result of that query, which will produce a different data set. And you can do different data set. This is basically how you do live analytics, right? So that's kind of the idea here. You can in this particular example, your limitations are just these two columns, but you can obviously give various filters, where clauses, and stuff like that. So I'll show you some query examples in a second. But out of this, you say dot exit to exit out of it, and this is this will continue, right? So there is no visualization aspect here, but you can see this is like a data flow that is running this sentence input data, just to maybe contextualize that in that manner. I can say Control D, Control Shift D. So I will just say Fluvio consumes sentence, and the sentence data is coming in like that, and Fluvio topic list. So most used words is the computed topic. So just gonna plop that here. It's gonna update every 30 seconds. So I say Fluvio consume. So this is something that you see every 30 seconds. This will update, right? So 59, 36, 31. Yeah, this is all of the data from the beginning, and every time the window kind of closes, it just updates that, right? Okay, so I think we have gone on for how long? Maybe, yeah, we've gone for a little over an hour, I suppose. Do you have any questions? Anyone has any questions about the workflow? Is everyone good? I mean, what is your sense of this so far? So use your reactions and whatever it is, maybe chat or something like that, and share. What is your Okay, perfect. So what I think we should do is we should take maybe a 10 minutes breather. Okay, yeah, the chat is enabled now. I see. Okay, I see. Yeah, so if you have any questions or anything, why don't you put that in the chat? And we can take 10, maybe, yeah, 10 minutes breather. We'll be back like 5 minutes after the half-hour mark for you, and then I'll go to the next example and to the next. Now, at least you see how to build one from scratch. I'm gonna do a lot more copy paste in the next one, so that it's a little bit quicker, because we got a couple of examples to go through if you can. But you can see how this kind of flows. I
Like,
thought I heard.
we use ChatGPT or some other AI for building workflows.
Yeah, that's a good question. So yeah, typically what I would do is, yes, I do use ChatGPT or Claude or whatever, right? Or Cursor, right? What we do with that is the thing with the YAML configuration is that it has to follow the syntax, right? Like you cannot have, you saw the couple of errors I got, right? The indentation has to be on point and it has to use the terms. So what I do, my setup, maybe I can show you that setup for a second. So in my cursor, let me just open this project, that's fine. But inside of my cursor, I have a setup, and I don't have a pro cursor, I'm still using the free one. Let's see, general features. Where is that setting? I'm gonna try to find. Yeah, so you see, there is in features a section called docs, and inside the docs, what I have done is I've added the Fluvio documentation link. This is basically the one second. This is this website right here. Yeah, this is this official docs link. So fluvio.io. I have added that over here. This is the docs indexed, and it updates the index. And the other one, this SDF example code, is the stateful data flow examples repo, right? So I will basically go, and when I'm using AI, I will say, let's see, what do I do? Say Helsinki Transit. Maybe I'll come in to this data flow YAML, and I will go step by step, and I'll say, hey, look at this types example, and in the documentation, all the types are there. And then I'll give it the input payload of the data that I'm getting. So Helsinki Transit or whatever data I'm working with, I'll give it the input payload, and I'll say, hey, can you generate the types for me, right? And typically it gets like 80-90% there to build out the YAML file and things like that. The functions, it can do a decent job if we say what it is that we want to do with the function, right? Because again, the operators and the primitives are fixed, right? It's deterministic, so you can like use whatever the documentation has, and you say, okay, I want to take this operator and I'm going to forward it, and then it's just a matter of going and compiling and building it, right? So when you build it, the other good thing about the fact that this is written in Rust is that the error messages are very intuitive, right? You can find out where you might have made a mistake and stuff like that. So couple of iterations, 2-3 iterations, you can actually use ChatGPT or Cursor or Anthropic, Claude, and stuff like that. The only important thing is to give the input of like, hey, here's the documentation, here's some example projects, and I'm looking to generate a file that looks exactly like this. And don't even try to give the whole file and say, oh, just give me the whole file back. That would be probably a little bit too onerous. I try to chunk it up, and I say, okay, I want to just like do the types. Here's my input data. Here's the example. Here's the documentation. Can you give me the types for what I need to work with? And then the types to topics mapping is pretty easy. And then when I'm coding the services, I would want to like look at examples of existing services and say, okay, which one is the closest one to what I'm trying to do? Am I doing a filter operation or a group operation? The state operations, the key operations, the window operations, they are pretty similar irrespective of where you're applying it, right? It just takes the schema and applies it. So and then you just go through the process of building it a few times at this level of abstraction, and as long as it compiles and runs a data flow, and the UI flag is helpful in that it gives you a structure of what this is doing. And let me just hide these lines here. So you see what is happening here. There's a sequence, right? This is what we call a DAG, right? There's an input data. This is a service. This is running over 30-second windows, a sequence of operations, right? Split sequence, assign timestamp, assign word. So once you see the output, it has to be pretty logical and deterministic. And that's true with anything data, because now you're like number crunching and you cannot make like random mistakes, right? So that's kind of how to think about it with AI assisted workflows. Any other question?
In the next demonstration, can you purposely make an error and show us how to fix it?
Is there a specific type of error that you're looking for?
No,
Because I had a couple of YAML errors trying to compile already.
Yeah.
Yeah. So the errors are typically the errors you'll find. Okay, if you want me to make an error in a function or something, I'll try to see. I probably have some like YouTube video or something like that. I can try to see if I can get an error or not. That should be fine. I'll try it. If not, I'll send you a video or something.
Okay, so
awesome. All right, so let's take 10 minutes. It's 2 o'clock for me, which means that it's It's half hour mark for you. Just be back in 10 minutes, right? I can't do the calculation right now. Whatever we can probably say India time now. Yeah, 11:30. Be back 11:40 or so, 41, and we'll continue from here.
Hello, sir. You're muted. Could you please unmute yourself?
Currently, we are on a break for 10 minutes. We'll be starting soon.
Oh, sorry.
All right. I think we're gonna just warm up to get started again. Uh, let's see. So there is that. I'm just gonna show you a couple of things that will be relevant when you're developing just locally. And this is not for deployed uh, live project, obviously, which you troubleshoot in different ways and stuff like that. But this data flow now, obviously, we have run it, and um, it's the connector is running everything. So just going to show you how to do the cleanup. Right? Uh, let's see here. Gonna first push. Yeah, it's just gonna get all this history stuff, which I need to not. Okay. So before I push it, what I should do is, so you see this is running right now, right? I'm just gonna close out of it. For stateful data flow to exit, sorry about the infinite. So just gonna close those streams. When you're running SDF, right, it will have this prompt, and you can always like show state here, and it just, or maybe show, and it says what you can see and so on. So you just say exit, right, and SDF clean, and you can put in a force flag. This only works self-hosted locally. This is for developer environment only. So when you do that, it would remove the topics, and it would remove the data flow. That's the cleanup, and you can get rid of this stuff. Clear, and then once you've done that, you can get rid of the connector stop because we deleted the topic. That's why. CDK deploy shutdown, and just pass in the name sentence connector. That's just cleanup, right? Best practice for cleanup. So you free up some space. That's all good. Now, yeah, that's much cleaner. Okay, thinking dot log. So I just need to do some git ignore extension so that it doesn't upload all the unnecessary files. And like I said, I will ping the link of this repository on my personal GitHub, and you can get the code. You don't necessarily need to, because I've given you all the other repositories anyway. But yeah, this repository might be like a list, and to access others. We move on to that. Okay, so now word count is done. Let's go to the Helsinki transit one, and um, we saw the connector part yesterday, so we are just going to go from that connector to building some functions, some logic on that data to get to basically get some analytics on that data. So I'll just do that. So let me see here, get the connector configuration. Give me a second. File MQTT. Okay, so let me just get that over here. So Helsinki Transit, I'm going to quickly create a file here. And you can say MQTT Helsinki .yaml. Okay, I'm just going to copy paste some stuff here. Command I to generate code. Maybe I can get a copy from here. This connector, even though it's a different connector, but the structure will be the same. Okay. So get that. QTT Helsinki YAML, and we just update this one to say Helsinki Transit Connector. Let's just use the older API. One MQTT, so CDK deploy, not CDK deploy, CDK hub list. And MQTT is 0.2.9. So I'm just going to copy that just to get this stuff from here. That's 0 to 9. MQTT source. The data that I'm getting. The name is MQTT Helsinki. And the data again go to Helsinki. So in the old API, the topic would just have the name. It's a little simpler. The URL. Okay, so just get the URL here. Okay, so this is the same thing that we looked at yesterday. So just by way of reminder, or for anyone who did not attend yesterday but is there today, HH Transit Finland, they have their real-time vehicle positions API here. MQTT broker. You can see you're going to this and message structure. Okay. So you can see there are some examples here, and this is the structure, right? This is the structure that you get. And these are the different event types that you can get. There's a ton of data on this actually. So we are actually working with this vehicle positioning payload. The reason why I'm showing you this is because the JSON transformation that we do, we pick out the specific part of the payload that we want. We don't even take the whole payload, right? And there's just one of the, you see VP is vehicle position. Um, there are different event types. This DU1 is a different event. The arrival is a different event, right? So these are all various events, and there's a ton of information on this which you can look at. If you wanted to even extend this example and build something similar, I mean, there are other transportation APIs that are from other places as well that you can access, but this one is pretty robust, and we've used it for a while. So this is the actual like example payload of what we are going to work with. Obviously, you're going to not get everything, but the place to access it is to go to the URL, and we're going to get JSON data from MQTT source. Right now, for the transforms, you're going to change that, and instead of using Jolt, you're going to use Jack. And I get a transformation there. The idea is quite simple, or quite similar, just using a different smart module, and we are running a jQuery filter, and you can see what we are. I mean, so this is a little bit different syntax, but we get vehicle, timestamp, speed, latitude, longitude, route. Right, the same data we are getting, but we are going to use this different smart module to apply the filter operation and filter the data from this. Right, this is the vehicle. This is the timestamp, latitude, longitude, speed. Right, we're not getting. I mean, there is all sorts of other stuff. This is odometer reading. There is, I suppose, acceleration. Right, start, stop, route, bunch of stuff, right? So we are not getting everything. We are getting route, latitude, longitude, speed, timestamp, and vehicle, right? That's the connector. I need to install Jack on the cluster. So Fluvio hub SM list. Let's see, where's Jack? Okay, that's there, right there. So Fluvio. Module download. I can say SM here. We'll download Jack to the cluster here. Good. Okay, so that takes care of getting the data. Now we can think about the data flow and what we can do with the data flow. Okay, I think that's good. Let me just run this thing here. Okay. All right, so we gotta download the connector. The MQTT connector, that is. Okay. Oh, and I forgot to create a connector directory here, so I'm just gonna move this stuff here. So Helsinki Transit should say connector, and move that inside of connector, and the YAML file inside of connector. Okay, that's cool. And then here in Helsinki Transit, we will just say data flow dot YAML. We just keep that open here. Okay. Let's see. Okay. CDK hub deploy. Actually, sorry, I should be CD connector. What happened to the? Hold on 1 second. One second here. Okay, CDK deploy. Start 029, and it's MQTT. Failed to read. Okay, let me see. Maybe. Okay, it's a file. API version 0.2. Type MQTT source. Topic Helsinki. That's interesting. Let me see if I can fix this here. This is not the error that I was intending to create, but now that I've created it, let's see here. Helsinki. Well, it looks like it's the same thing. I hope I've not messed up something here. Meta version. Let's see. Okay, BWD, where am I? Connector. That's good. Got the package. Oh, sorry. Gee, that's a stupid one. Sorry, I was looking at the wrong file. Oof, it's not. Sorry, I think the night is catching up on me. Okay, there you go. Deploy list. Okay, that's good. Okay, this is obviously really, really fast. Close that. Okay, that's good. So we got the Helsinki data. Let's kind of build a data flow here. And then we can see what we can do with it. And I'll try to create an error by putting the wrong data type or something along those lines. So let's see if we can get that set up. Okay, so go bit by bit for the data flow YAML. Okay, so first start with the API version. This is Helsinki stats, namespace my.org as an example. The configuration, same thing as the previous one. Just going to copy it from the last data flow. You can do that as well. It's the same. Whatever we have here in the config is pretty much the same thing we're going to do here. Config JSON. Okay, so we got that. Okay, get rid of that now. Now in here, the types, right, are based on what you're getting in this data, right? So we scroll back up. This is the payload, right? This is what you're getting. So this is the type that you will declare: vehicle, timestamp, speed, latitude, longitude, route. That's the input data. Okay, and you can see this is obviously there's a timestamp here. There's a floating point. There's integer for the route, and then this one looks like string, right? And we're going to use the times. I mean, so whatever is in quotes obviously is string, right? So and then the other ones are float and integers. So we can start with that here. Excuse me. So each event here that we're getting, that each event object that we're calling here. So you got the vehicle, integer, speed, float. And these optional equals true is because in some cases, this is just to deal with missing data. So you might get a record which does not have this because the data is coming so thick and fast, and so many records, sometimes it might have missing data and stuff like that. So where the GPS doesn't capture the accurate latitude, longitude, and sends like a blank value or stuff like that. So you just use optional equals true to deal with data that may be incomplete and things like that. So that's event types. Now we'll have to describe what are the types that we are going to use to well, let's just say what are the types of the output that we're going to produce, right? So this every event is actually sharing a vehicle position, right? And we will call that a specific object here. So vehicle position, this is the same as the event properties. If you look at it, it's the same thing. Same idea. We just creating a named type for the vehicle position. What will happen is we're going to get the events, and we are going to apply some kind of basic filtering logic and say, okay, just remove all the events which is incomplete, and only give me the complete records and load that into vehicle position. So that's the idea behind event and vehicle position as two distinct types with the same exact schema. We just start with the raw events, let's call it, and it might have missing values and stuff like that. And we're going to apply some basic logic to filter out all the incomplete records right out of the bat. And it's okay because it's just something that moves really fast. And we're going to compute average speed. Okay. So average speed object has got vehicle, route, and the speed. And then you pop that into a list like we had with the list of words. Same idea. So it's a list, and it's a list made up of this. Right? So you can see this is all the types that we are, or all the schemas that we're going to work with. So you work with raw events, and I thought I had figured it out. Okay, so there's raw event, there's vehicle position, there's average speed, there's average speed list. Right? Now, let's get the topics put in. And the topics are basically going to map with the Helsinki topic would have this event data. vehicle position topic is going to come from that event data. And then we'll have an average speed topic, which will be the output of this list that will go in there. That will be the output of the average list. So you can have events. The name is Helsinki on our cluster, and the schema is event as we describe up there. Vehicle position is the vehicle position, and average speed is the average speed list. That's the topics, types. That's done. Now we go to services. Let me see. I was thinking about maybe. Okay, yeah. So maybe we will do a type error, just so we can see like a schema validation error type of scenario, right? And let's see, how many services do we have on this one? Just a second here. Clean events and vehicle stats. I think that's it. 2 services. Okay, so let's do that. Topics, events. So now in this case, actually, this is going to be interesting because we're going to use like a chain of services. And this is the right sort of build up from one to the other. So let's go to services, and we'll call a service clean events and apply a simple transformation. So let's just plop that in. I'll just walk through the code here. Services. Where's the S gone? Okay. So services, we have this service called clean events. Okay. And what it does is it looks at the events and applies a filter operation. So here in the transforms, applies a filter operation. And in the filter operation, it's running a function called remove incomplete events. Okay, so it takes in the input events and all the optional data, latitude, longitude, speed, just make sure that there is data in there. That's it, right? So it will allow all of the events that there is some data in speed, latitude, longitude, where we have seen in this, there could be incomplete data sometimes. And that's what will be allowed. It's as simple as that. And then it'll add a timestamp formatting here. So there's a map operation. So in this transformation, there's 2. The map operation calls a dependency library called chrono to apply timestamp formatting. So in the clean events, the second thing that it'll do is to look at the date time, the timestamp, which is string, right? It will use this naive date timestamp to parse that string into a timestamp and keep the schema the same, right? The vehicle position schema is vehicle, route, speed, latitude, longitude, timestamp. It's just going to take the timestamp that we get in the data, which is string, clean it up, parse it, and put it in as timestamp. And that will put the data into the vehicle position topic. Okay, so raw events to vehicle position. Now, these vehicle position topics will be subject to further operation where we look at the average speed and aggregating that. Let's see here. So clean events. That services clean events. This should be the next service here. And we're gonna do the next service is, you would find that next service is very similar to the word count service that we just did, because the structure will be the same in many ways. But let's collapse this clean events one service. So now generate vehicle stats, right? So it takes the source topic is vehicle position. So as we see the graph of this built out, you will notice that it works with the output of the clean events service, which is the filtered version of the raw events to the vehicle position topic. And then it applies this similar structure of transformation to apply state on this, apply timestamps on this, and materialize this data, right? So that's what it does. And then that pattern opens up many opportunities essentially to then apply various transformations. So here we've got the source topic is vehicle position. Then we we initialize the state object here. So vehicle state, keyed state, and this is the property. Put that into an arrow row, and every unique route and speed then forms the value um, of this keyed state. Then we run tumbling window operations. This is every 5 seconds. The timestamp assignment is not giving an event timestamp this time. In this case, the assignment timestamp runs the function to just pluck out the timestamp that we parse in the previous service and use that as the timestamp. So this is basically the timestamp of the record or the event rather than when the event is processed, right? Then we got the same thing. So partition assign key. So it's grouping by the keyed state, right? So it's looking at unique vehicles and their routes. Then it updates the state, which is to group like the group we were doing. So in this case, you can see it in the update state, it applies an average speed computation. So it looks at every route, looks at the speed, and it calculates the average. And that is what it updates. And then the flush every 5 seconds, it's going to collect the stats. The reason why this window is small is because you're getting so much of events. If we take a 30-second window, the computation will grow, and you're just like being prudent with our system and how often we're updating. And also in this case, I mean, 5 second is a pretty decent time frame, if you will. If people are waiting for a bus and every 10 minutes there's a bus that comes to a stop, you don't want to wait for 30 minutes to see what happened, because the buses move probably 5 different stops in that time. So obviously the time window is aligned with this, and when you do the flush every 5 seconds, it's going to get all of that data, and it is actually selecting everything from vehicle stat. That's the SQL that it runs here. Shows the column of the speed and the route and the average speed, and plops it there. Now you can say that you can modify this service. I mean, what's the point of monitoring average speed? Might be, the transit system might be monitoring, hey, if there's someone over speeding or something. But for a consumer, you can take the same data flow and think like, if you're standing in a bus stop and you've got a mobile app, and you want an estimate of how long will the bus take to arrive to you, if it's on time or not, running late or not. So there are many different types of computation that you can run on this data. The average speed is kind of one of monitoring from the operator of the transit system rather than the consumer. But it's just one pattern. But you can take this pattern of service and create many different services which will apply similar computations. And the structure will always be, there'll be some state that you would initialize, there would be some timestamp that you will work with, and then you would choose the specific columns, the numeric values that you want to apply computation on, that you want to count on, that you want to get the average for, that you want to get a statistical distribution for, and what have you. And you would initialize that function in your update state, and everything would be grouped by key. And then you will flush, which will be basically window-based operation when you're doing tumbling or sliding or whatever. And this is what will be going to the average speed topic there. Now, just to emulate some kind of what you call errors, most of the errors that will come, other than syntax indentation, missing this, missing that, would be related to schema validation and types. Most of this, that's what it would be. And if the service expects a certain type of data, and it's getting a different type of data, well, obviously it's not going to process it, right? So I could probably say that, okay, here's the event. Let's say I changed the value of timestamp to, or let's see, the speed, where was the other string? Route is string. So let's call this route I-32, because actually if you look at the data, right, where's route? I think, yeah, there. So it's actually string because it's within quotes, but you might think that it's an integer, right? So let me just say I32 and put that in here. And this is where you need to do like some kind of cleanup here, right? So assuming that you made that mistake, when you try to build this, you will get an error with the type. So whenever you're building, whenever you're running the connector, you need to be in the directory where there's a connector configuration and the connector package is referenceable self-hosted. On the cloud, you're just like referencing the connector and passing the config. But that's that. And whenever you're building or deploying a data flow, you always have to be in the directory which contains the dataflow.yaml, because that's what it uses to build the entire project, the scaffolding, code generator, and all of that, right? So SDF run UI. So now it started building because there's no syntax error, but it will get a type error, or it will have an error with the actual data. So you'll notice that this data flow will actually, I don't think it will fail in building, but it will fail in the schema validation because the actual data will not be processed. Okay, there you go. So you notice now it was going through building all of this stuff, right? It gives me, and this is actually a thing with Rust. Like it tells me all the things that it has compiled and it's able to compile. Okay, now here is why Rust is so amazing. So it says that route event route try using a conversion method to string found I32, because here's what happened, right? And you could think of a situation where it's vice versa, right? Like you may think that this is an integer, although you may not. I'm just like making this up. You may think that this is an integer and say this is an integer, and you may not like do the type conversion here, not here, in the clean events, right? Because this is where we do the conversion. See, latitude, longitude, speed, event route. Yeah, so we are defining the schema here, and it's like trying to look at this structure, and it says, okay, no, this is not clear, right? So event dot route, try using a conversion method to string, right? As it builds the function, it has got mismatched types, because why is it that we are trying to run this type, and that's the error. And these are other helpers. You can say explain, it will tell you why the build failed and so on. We know what the error is because this was kind of deliberately created. So here also the route is string, right? Operator map Chrome. Times I need to see. So let's just bring it back to string here. So type errors are what you see. Now, if you are able to build and compile it without an error, and there's a mismatch because the function and other stuff is consistent, then the error will actually happen inside of the data flow. So when it starts running, it will start throwing error in every record that you see, and it will say it's failing to do the translation, and it's expecting a different data, and it's getting a different one. So I'm going to do that. SDF run UI again. It's going to build, and notice it just did it faster because it had done all the other work, and it had kept that stuff available. And here is your data flow. Let's see. So we got events, goes to clean events, which removes incomplete events and cleans it up, applies timestamp, sends it to vehicle position, and then This service runs 5-second tumbling window, assign timestamp, assign key, collect vehicle stat. This is the state, and write it to average speed. So you can see that these are the different routes. You can see the key there, all of these different buses and stuff like that. I actually have to dig up the project. There is a GitHub project that I have somewhere where these buses, I can visualize it based on their latitude, longitude, moving like you see on your Uber app or some delivery app and stuff like that. So the buses actually move on the map as we plot their speed and stuff like that. I have to look it up. I don't have that example offhand, but yeah, this is Helsinki Transit processing this data. What can we do further with this? Maybe we can go in and see. So you got vehicle state. Let's see here. Can say show state. Right. Let me see if we have SQL here. Show table. Okay, so select platform vehicle underscore stat limit. Okay, so you got the key, got the route, and you got the speed. Okay, so well, 2-3 columns. It's like you can't really do joining and querying and stuff like that. But if you have more columns that you bring in, you can add, and actually you can add some other attributes to the payload. So I can modify. So basically, how I would take this data flow and tweak it, which is another neat exercise for any of you to try, is okay. Go to the connector. You know that we are not taking the entire VP payload, right? Vehicle position payload. We are only getting 6 columns. Is there any other column that would be relevant for us to build something? So let's see. We got the odometer reading. We got the start time. Let's see what else. Example of message. This is the definition. Vehicle position. When is the vehicle due? Vehicle arrives inside of a stop. These are event types. The payload. DL. 1 second. I'm just making sure that. Yeah. So there are the field descriptions. So route number, route direction, operator running the trip, vehicle integer, test strings, timestamp, TSI, Unix time, speed, floating number, heading of vehicle, latitude, longitude, acceleration. Yeah, so there are cool things that you can do with that. Like if you look at the acceleration, you can probably move the bus at the rate with which it is accelerating. You can say when a bus stops, there is door open, door closed status, which shows up. There are you can look at the descriptor and the line, and you can create a map, and you can figure out the calculation of how long it will take. There are a number of things that you can do with this, right? And you can try and pick out some additional columns, modify this filter, add some additional attributes that you want to capture, build a data flow. Now, in the data flow, when you are running this window operation, once you've stored the state, you want to in the operation not just produce like 2 or 3 columns. When you are producing the window-based aggregate or in a time window, just produce a slightly more wider table as a record, right? Or you can have 2 different services produce 2 different outputs. One, just the consumer side, how long every route is taking to arrive at the next stop, and if it's delayed or if it's not delayed. And then you can do the average speed, and you can then join the 2 in the SQL query and then correlate that. I will show that example using the New York taxi data that we saw yesterday. But yeah, you can do queries depending on how you are shaping your data, which is flowing out of your topics, right? So that's kind of the idea. This kind of brings us to this point where I just want to show one more, which is like the Open AI API callout. I will go to that first, just in the interest of time, and then I can come back and show you the more complex SQL queries on the New York Transit one, because we actually ran the New York Transit example yesterday, so we kind of have a sense of how that operates. So I'm just going to go to the Open AI one, if that makes sense. Just before I do that, I'm going to clean up this. So if you want to raise your hand if you have any question. So while I clean it up here. Okay, seems like everyone is okay. Then if you have a decent understanding of all that went down so far, just react. So at least I'll see some reactions to know that you've got it. So shut it down here, the Helsinki MQTT. Yeah, I just specifically when I'm running the Helsinki one, I like to clean up promptly because it's a lot of data coming in. And I'm running all of this locally. So yeah, we have the New York Transit one open, so we can take a look at some point after. Okay, so let me just go to that and then go to the open. Actually, should rename that. Should be Open AI call out. So this is one other thing that you need to sort of be aware of when you're building stuff. Open AI is just, I mean, I'm trying to kill two birds with this one stone in here. You're calling an API, right? So you can call any API. Doesn't necessarily need to be an Open AI API. For example, let me see if I can show you. The stateful data flow examples here. Stateful data flow examples. Okay, so example in this data flows, I have an example of. Oh, did I not merge the pull requested? Hold on, what am I looking at? Data flows. This is the OpenAI callout. Okay, there are a couple of branches that I gotta put in, which I've not put in yet. So there is this traffic cameras object detection. Oh, I see what happened. I had to clean it up. And then there is this blue sky Fluvio. I see. Okay, yeah, I remember. I actually was trying to put something in and then I had to like clean up because of security and stuff like that. So there are a couple of examples where we collect data, and these data flows would eventually make callouts to various APIs. So this Blue Sky one uses Blue Sky APIs to capture the data and bring that into Fluvio, and then make calls to Hugging Face for sentiment analysis and stuff like that. So you can call any and every API is sort of the point here. I will show you this example. This example is here, and again, I will link you to it. But just be aware that within a service, you have operators, and you can use those operators to make API callouts, which is the pattern that we are using in order to reach the OpenAI API. So in effect, you can build a workflow which is considered, let's say, agentic, using stateful data flow, because state machine state management is a pattern that we use. We also have internal project to connect with MCP, Model Context Protocol of Anthropic, and a bunch of other things that you can do. The possibilities are endless. I'm just like showing you a pattern that is quite interesting, and you can do many things with it, is sort of the point. So just keep that outlook in mind as we talk about this open AI API callout. And this is fairly straightforward the way we want to do it. In just gonna write the data flow YAML file here, and start with the same thing. So API version, metadata, configuration. Most REST APIs going to work with would be most REST APIs would be JSON, right? So this is what you're going to work with. And then in this case, when you think about chat interfaces, right, you have to think about messages that are being passed, or agents, if you will, messages, and then it will start with some kind of input string, and then it would go back and forth, right? So you can see here the types starts with a sentence string. We can even use our demo data endpoint to pass it in. There will be some chat request, which will take the input string and pass it to a model. And then there would be a counter that will count the attempts, because you're hitting an API and you might get errors. Then we'll keep track of requests, and the requests will go to specific models because there are different models that are available, right? And you will send messages, right? When you pass a message, like a prompt or a question, you will send a message, right? And that is what forms a request. So you can see that the request requires a model and messages. Messages is a list of message, and messages object with property, role, and content. Okay, so those are the types that we use in this example. Now, once we have the types, the topics, kind of same idea, but topics are the input sentence, right? Gets the string raw, and the output, it produces the output, which will give you the chat. And then the services. Now in this, there's only one service, but it's a tad long, so I'm going to walk you through that slowly. Topics, okay, service. So there's this OpenAI service here in this case, where it takes source topic sentences and it looks at, it declares, initializes a state, count per model, which is a keyed state, and there's a key value here. Now, notice the transformation operation runs a parser to parse string input. It has to tokenize, get the words, split by white spaces, initialize a model, and you can see there are a bunch of models, and we just looking at 3.5 and 4 easier chat requests. Some of them are older, and then based on that we have chat requests, and there's like a conditional, right? So you're just sending your input to a model, and there's like a default state where you're just sending it 3.5 or something. The partitioning is the same. It partitions you by key. Now this is where the actual call out happens. So you can see here's the map. It uses a package called SDF HTTP, and we got a package published to make that call out. And it expects JSON. It runs a chat request. Now here is where these kind of things you have to be careful with. Just don't. We have elaborate authentication, secret management, and all of that. Please don't put your key here. In a cluster, you would store it as an environment variable and secret, and it needs to not be exposed. And then we use this key, make the request, get the message, deserialize the response that we get because you're going to get a request response. And these are all like just working through that, right? So prompts, tokens, um, here's the request. This is basically whatever you need to do to access the API. So like this is just like conforming to the structure that we need to use to make requests to OpenAI. And here's the body of the request now. So 30 JSON request body. When you're making HTTP requests, there are headers and stuff like that. So here's the request builder. You've got the URI where you're sending the request. Here's the method post. Here's the header of the request, content type, and you're sending JSON. Here's the authorization, auth bearer, body, all of the parameters. And then you send the request, expect the response, get the body. Once you get the response, you have to apply the SERDI to get the output and produce the output. And you keep a counter to look at attempts and get the output, send it to the user, and just keep track of failures and things like that, and produce that output to an output topic. Right. So that's a service. Now this is not happening in a window. This is like asynchronous, right? Or this is not like time bound in a window. But this is our pattern of making API callouts. Now, when you're making callouts to the API, it will have to be authenticating based on how the API wants you to authenticate, and it has to be sending the format of request according to the API and so on. So this part will look slightly different for different APIs that you're working with, but at the end of the day, you can make this asynchronously as a part of your workflow, and that's that, right? So now, let me see. I actually got an OpenAI key, temporary. So let me just copy that. I hope I didn't delete it. Okay, there it is. Oh no, I deleted it. Hold on a second. Okay, maybe I can go to my API, create a key. Yeah, this stuff I'm kind of whenever there are keys and stuff, I did create a key, but I don't think. Well, let me just revoke this. I can't really make use of it now. I'll just create a new secret key, paste key, and copy that. And then I gotta be here. Stateful data flow cd open AI call out. And I gotta say SDF run -e. Typically, you will have the environment variable as a file and store that in a thing. Well, I'll just. This is how you pass the thing. You will just pass a file, but in this case, I should say open AI. And last time I was running Hugging Face, so you see Hugging Face, right? Open AI. Don't copy my key. I'm going to delete it, but when you run it, let me see. Data flow definition config option value expected internally tagged enum. Okay. I gotta see what I messed up here. Option value expected. Hold on 1 second. Let me just try to. See if I can build this data flow here. So I messed up the config on this one, but okay. So topics created, output and sentence, show state. Okay. So then what I should do is maybe let me run the word counter connector here because I was going into sentences, and I'll run that for a little bit. It's gonna open a new thing. Cd. HTTP 0.4.3 and then -c quotes connector Q. Okay, so Fluvio topic list. That's sentence and outputs of Fluvio. Okay, and then Control Shift D. I don't want OpenAI to be angry with me, but let me see if I get something in the output or not. Consume output. Okay, so let's see here. Show state. Okay, there's sentence. Let me see the OpenAI service is running on show state. Okay, so notice the OpenAI thing is failing. This is good way to test the observability. So I gotta now look at the log. So what I'm gonna do is Control C, exit. Now you can build it in debug mode if you want to build it in debug mode. You can also look at the SDF runtime API socket. Service parse mode. Okay, so this is actually like the project that it builds, right? And I had to troubleshoot that history OpenAI service. So that's what we did. Request operator results success. Okay, so this is the build succeeded, history of it works, the runtime log. So I have to run this basically in debug mode. Let's see, SDF. Okay, but with the API key, so it's probably like, all right, okay. The other thing that could be is that I don't have credits, which is probably the case. Yeah, okay, that's fine. Okay, well, I should, I've already, I need to reset my budget to run this example. That's probably why I was using the Hugging Face one. But what I will do is I will share the Hugging Face example in the interest of time so that you can try it out, because it's 3:12 and I know people have questions. Let me stop sharing and see who has their hand raised. I thought I had someone whose hands were raised. Like, can you ask your question, unmute yourself and ask?
So can you use Grok instead of OpenAI? It's free now.
You mean
Grok.
Grok?
Yeah,
Like the
Grok.
yeah. You can use any API basically, right? So I have built an example using Open Router. Like you can go to places which gives you multiple um, language model providers where you can get Llama. I have tried building with like a local Llama server. Hugging Face obviously has a lot more models, right, and a lot more vanilla and smaller ML models than just large language models. You can do a lot more things with specialized models for vision and things like that, right? So there are examples that are there. I actually had some ideas around like recording some videos and giving maybe like between now and the hackathon, maybe I'll record like a few videos of going through different examples of machine learning and AI pipelines that you can build. But yeah, short answer is yes, you can certainly use Grok, you can use Llama, you can use anything that you can access over an API. And um, instead of OpenAI, you could use Open Router. But any API you use, there is always like rate limits, and you have to have some kind of tokens and get access. And running specifically language models are expensive, right? So that's why you can go to like some Hugging Face model, which is smaller, not necessarily deep learning, not necessarily large language model. It's some kind of traditional computer vision model or classification model. Would still be a great demo, so it would still be a great project, but would be a little bit easier to access or faster to access compared to the large language models, which are always under tremendous amount of traffic and load, right? But yeah, you can use it. So maybe we can say this is probably a checkpoint. It's 3:15, so the time has flown by. I hope it has been as exciting for you as it has been for me. So maybe we can take a quick moment because obviously people have uh, some people have dropped off and stuff like that. So can you just like do a quick? I think like some 20 something people that are remaining on the bridge. Can you just do a quick reaction on? All right. Gotcha. Excellent. So that
Uh,
stuff at least tells me that you got something. Yeah, Kanish, do you have a follow up?
yeah, one more question.
Yeah.
Like you initiated the API key with STF run dash e something, you know.
Yeah.
So, can we create an environment variable and do the same?
Yes, that's the ideal way. So we have like a full secret manager where what we do is even like the example that I was showing about GitHub to Discord and Slack, right? All of the tokens that you need, you store in a .env file, right? And you load up that environment. So that -e is pointing to an environment variable. It- mm, we are just passing in the key just as a shorthand instead of passing in a file. But yeah, you would want to ideally have a file, and that file should not be synced. It should be in your git ignore. It should not be synced to a repository or anything, so you safeguard your key. And yeah, you pass that file in. When you're using cloud, you can say, okay, set secret. So if you look at the Fluvio documentation site and search for the word secret, we have a secret manager that manages all of these secret tokens as environment variables when you're running it in production deployment, and it ensures that it is tied to your MTLS authentication and it's not exposed anywhere and this kind of thing. All right, so maybe we'll spend like 10-15 minutes to answer any questions that you have. So two days, hopefully most of you that are on right now have spent both the sessions. I think we started with like over 150 people, but obviously everyone, Saturdays and Sundays, I appreciate you joining and sticking around. And again, all the people who are participating in the InfinyOn track, I don't know if Pradipto is here or not, or who all from the organizers are here. I would need the email addresses if we can have a list of everyone who wants to participate in that track. And I will create cloud accounts so that they don't have any challenges downloading the packages and stuff like that. Let's use the next 10-15 minutes to answer any questions that you have conceptually with respect to event streaming, broadly the landscape, use cases, markets that it apply to, or anything around the demos that I've showed you. Whatever questions you have, raise your hand, and let's Yeah, clear any doubts that you may have.
Hi, Dave.
Yeah.
Yeah, I had one question basically from a participant, so
Yeah.
it would be better if you could clear it. So the question was something like that: if someone is on the InfinyOn track, so like, are they restricted to that track, or they can, incorporate other technologies as well? Let's say they incorporate Grok into their
Oh yeah.
project, or they
Yeah. Yeah. Yeah.
incorporate NAD or something. So yeah, that
Yeah.
would
Yeah.
be.
Yeah. Yeah. So the thing is that we are, if you've seen, right, we are a horizontal platform. We are agnostic to the data, to the schema and stuff like that, right? Our customers, they are collecting data from all the way from sensors which are on cars, bikes, boats, trees, whatever is being measured, to APIs like Stripe, Shopify, Plaid, to calling other APIs, language models. It's pretty broad and deep, and we are not, what would you say? We are agnostic to any of this, right? So you can, if you are participating in the InfinyOn track. As a matter of fact, if I was in your place, there are 3 4 sponsors of the hackathon, right? And InfinyOn is infrastructure, right? So I would take one of the crypto tracks, and if it's possible, I would work with their data and build a use case of like off-chain Ethereum or off-chain Solana analytics using InfinyOn, right? Like we have customers which are doing that. So you can certainly integrate with any and every data source, even if it goes to other sponsors or other tracks. You can also integrate other products, whether it's APIs or integrations with our stuff. Now, the only caveat, again, like whenever you're doing a hackathon and you want to win, you have to always consider the amount of time there is and how much effort it takes to do something or another, right? And I hope you have seen that the platform that is Fluvio and Stateful Data Flow and InfinyOn, you can actually have very, very granular level access to specific components, even to the extent of your raw storage, raw processor, raw memory, etc. If you go down to the Rust compiler level, then you go on top of that a level of abstraction where we have some boilerplate code, some scaffolding, some tooling to build helpful packages and functions. On top of that abstraction level is you build data flows end to end to process data, manage schemas, get output, which gets closer to the actual use case someone is looking to solve, right? So you want to figure out, based on how much time you're dedicating to this project, how, at what level of abstraction you want to spend more time and integrate. And if you want to integrate other streaming solutions like Kafka, you saw we have a Kafka connector, or NATS or whatever. um, we don't have anything against it. There are only 2 things I would say. One is, how much time do you want to spend? And 2 is, going back to yesterday's question, someone asked about what is the judging criteria. Specifically, I will tell you, InfinyOn as a company is predicated on this idea of less is more. Okay, we are all about efficiency. We are all about effective data flows, right? So you can go to any data architecture randomly, people building data intensive applications just for the heck of it, putting 5 different technologies, right? 3 databases, one for search, one for this, one for cache. Those products are very hard to scale in that way profitably, right? Like if you have 5 different products that you to manage the infrastructure for doing one thing, instead of using like 2 products, maybe you're going to spend more money, right? So I just want to highlight that point, that our judging criteria would also consider like your design efficiency. So if you can have a simple solution utilizing our pattern, you don't want to overcomplicate it just for the heck of it, right? Like so those are the 2 balancing acts, but you can use whatever you want to use alongside our platform. There's no restriction. I know it's again a long-winded, detailed answer. Hopefully that answers that. Pradita, is that good enough, or do you think any follow-ups?
Yes, yes, yep. Yeah, we have been obviously telling everyone that, yeah, you can always use multiple tracks in your project. It only enhances the attractiveness while judging.
Yeah, and honestly, like again, so I think like one of the things you remember that, see, the most attractive use cases, and this is just like a little bit of a pet peeve of mine. I'm just sharing this because I have these conversations with people who are like chief technology officers or architects at companies who are basically using my product, and we'll always like talk about this in this context that okay. Um, the highest level of value, and I mean maybe I'll give you one example because large language model everyone knows. um, I will probably even share this. So like you all must have heard about the Perplexity competition that happened during the ICC Champions Trophy, where you can go and use Perplexity and you could win a trip to their office and a bunch of money, right? I think it was like 1 crore or something like that. And they did the same competition over here. Now, the thing that you might not think about is that why is Perplexity doing that? Is it just like advertising or is it what it is? They are actually going in the side of sports betting and um, you know uh, payment processing and markets. And then again, you ask the question why, right? So the attractiveness of the project is not just, oh, is there some hype or some AI, some ML, some fancy um, application? The attractiveness is how valuable is this idea in the market eventually. Like when you're thinking about this, right? Don't ignore this, right? So if there is something that is valuable, that is probably in an area where there's a lot of money that is being invested, and it probably is not where a lot of money is being invested solely in a technology like AI or large language models. You have to see through that and double click and say, okay, what is happening in the context of, let's say, e-commerce? What is happening in the context of payment processing? What is happening in the context of hyper local delivery apps and stuff like that? So think along those lines, and then once you have an idea of like, okay, this is what your understanding is, what is it that you want to build, let's say crypto, high frequency trading, e-commerce, whatever, pick a lane. And then once you pick a lane, you figure out like a small slice of problem you can solve in that entire gamut, right? That is a nice way of sort of decomposing a high value problem, solving a small thing, and then pretty much try to stick to like, 2 or 3 data sources, 2 or 3 tools, so that you can manage to deliver a decent working presentation in the limited time that you have, right? So yeah, that would be my sort of recommendation, and then we are happy to help and support in any way we can.
Any more questions, guys? If not only regarding the Fluvio track, if it is about the hackathon also, we are happy to answer. And I hope it was a thrilling 2-day bootcamp. We promised you something amazing. So yeah, I think it was very informative and knowledgeable. If it was, please show some reacts, or I think the chat is disabled. So yeah.
Nice. I have one question, Pradipta. So what I was thinking is that I, or actually forget my thinking. You can tell me. My question is this: from now on, what are the rest of the things building up to the events, and how do we make sure that all the people who are participating in the tracks, I can activate everyone logistically so that they have everything that they need on their hands on
Yeah.
starting.
Yeah. So basically, we are launching the problem statements on the 4th. That is the next Friday. So people would have actually a clear idea of what they need to build. So obviously the tracks are shared, like you shared your track and others shared their tracks as well. So we would announce those problem statements, and moving forward, we will share a resource, maybe a common repository of resources where all the resources are placed. Again, from each sponsor, we would have some resources. For example, you shared your Discord link and the GitHub links. We will put them in a central place. We are currently in the process of collecting. Then, if the need arises, like the people who are here, if you guys would be obviously would be wanting some mentorship, In that case, you can always refer to the documentation. You can always refer to the mentors at the Fluvio Discord channel. You can always go there. And also, as you all know, the hackathon begins on the 11th. So you have the problem statement 7 days before it, right? So you have a full 7 days to actually, for your prepping time and all that. So in this workflow, Dave, how do you think we should? Uh, what are your suggestions?
Well, I think what I'll do is this. I will create a repository of some just tutorials which are not like in the workshop context, because in a live session, what happens is you're kind of going back and forth, and it's not just like, boom, 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 one. I mean, it's not, it's a little free flowing, right? So what I'll do is like, I'll have my repository of examples. I have shared all those things. I'll keep all of this stuff ready. The only thing that I will need a little bit of time with is to make sure that everyone has an account on my cloud, because what I'm going to do is I'm going to create a dedicated shared cluster on
Mhm.
InfinyOn cloud saying this is for hack hazards, right? And let's say because there's 10,000, I'm thinking like, oh, I mean, I don't know how many end up joining the track, but whoever
Yes.
wants to join that InfinyOn track, if you can figure out a way to give me their email addresses, I just need a little bit of heads up to create and share that shared cluster to all those people so that they can access and download all the packages. And even if they are running data flows on our cloud, we can help them and support them with that. That's the one thing. And the second thing is that, given what I sort of sense from people and their questions and stuff like that, I would want to like just chat with you once, Pradeep, and the organizers before you publish the problem statement, maybe sometime early or mid next week,
Mhm.
to make it, if we can make it a little more accessible or simpler, because I don't want to like make it too complicated um or too detailed or whatever. So it'll just like, I was thinking of slight tweaks to make sure that whatever
Yeah.
I shared in the session, it's consistent with that. People can certainly go above and beyond and build connectors and write Rust code and go into the weeds of the system, and I absolutely welcome that. But in the context of a winning group in the hackathon and stuff like that, we want to make the problem statement something that is a little bit accessible to a wider audience. So like, let's just connect and do that.
Got it. Yeah. And by the way, when would you need the emails? Let's say, because let's say if we announce the track on the 4th,
Hmm.
so there might be people who make up their mind on the same day. There might be people who make their mind maybe on the first day of the hackathon. So
Uh,
when should we
that,
ideally?
that's fine. That's fine. I can like, I mean, I can, if I get a couple of days notice, that would be good. Because right now in our cloud, we have made it in such a way that um, we kind of added a friction point for people to request a token, just to make sure that we don't get
Yeah,
thousands of people who are just joining like that. So
exactly.
yeah, I just have to set up the token workflow and issue tokens to all the people that want to join. That's it, right? So I mean, couple of days would be nice. But anyways, this could be a rolling thing, right? So even people who
Yes.
decide to join later, as long as the workflow is clear and the expectation is set that, okay, look, if you request a token and give me like, I don't know, like 6 to 12 hours, maybe I should say 12 to 24 given the time zone difference, I will get you onboarded, right? I have the cluster created, but I need to issue a token. The person needs to create the account, and once they create the account, there will be a cluster invite sent to them, right? So that those three steps need to be done, and I have one workflow to run from my side to like get people on.
Got it. Got it. We can do something on the lines that when we announce the problem statements, along with that, we would issue certain guidelines that if you require the cloud credits, fill up this particular form, and we can, connect you to the form.
Actually,
And
there is no cloud credits and all. I'll give you a cluster, all you can eat. It will be like for hack hazards, right? So if there are even 1,000 people on our track, they will
Mhm.
all be actually using the same cluster. So it's multi-tenant, right? So it'll be using the same cluster. It's just that the account is needed to be able to download the packages, even if you're doing self-hosted, right? So people won't be able to download the modules that are already packaged to do the transformations without the account. So it's not credit. So that's how I'm saying that we will. It's all you can. Yeah. It's not credits. It's access to a
Okay.
shared cluster. But yeah, you need to create an account to be able to download and get it. So just like mention it that way, and then yeah, we will set you up.
Got it. Perfect. Any more questions, guys, regarding the InfinyOn track, regarding the hackathons? Anything else you would like us to talk about, or we can wrap up? We should really appreciate Dave. It is, I think, 3:30 there.
Yeah,
Truly commendable.
3:33.
Yeah.
Yeah.
Thank you so much for taking up these bootcamp sessions. I think it was a very fun and informative.
Yeah, I hope that this is yeah. I just need you. This is the thing, right? I mean, again, I will repeat this. Every extremely famous vibe coding application that you can think of, like lovable.dev or Replit, Versal V0, Replit Agent V2, all of these, they are helping you build a lot of monolithic applications. And we have been writing software for 3-4 decades now. And yeah, those applications struggle to scale. So I'm glad that you all are interested in learning this. And yeah, I mean, I hope these are like seeds to help you in your career to grow and build really amazing software and applications. And all the very best for the hackathon. And I will be there to support and help you in any way for anyone who participates.
One last thing, should we start learning Rust? Because
that's, a, that's a good question. So let me. The last question is the most loaded. Should you start learning? No. So here's the idea. Um, Let me say it this way: programming languages are good for specific purposes, right? Rust is possibly the most effective, and I'm using the term effective, right? I mean, I could say efficient, it's fast, and it's
say
runs whatever. Zig is also fast and all, right? So it's like, look, if you're doing systems programming and you need deterministic systems that that does what it says it will do, um, Rust is a great choice. And a lot of big tech companies for the past 3-4 years or so, we started this project 6 years ago, right? I mean, it was not as popular then. It's growing. If you're wanting to write applications, Rust is probably not the best choice yet, right? But if you're wanting to write robust backend services, asynchronous services, distributed processing, compute services, it would be Rust, Go, in some cases Zig. I wouldn't necessarily use Java anymore, and Rust doesn't have garbage collection. So right now, like systems wise, and Rust is kind of more mature than Zig, so it is a good choice, right? But for your work, right, you have to think like what is going on. And I've worked in a bunch of different companies. I don't know if you saw my LinkedIn or not. If you're looking at manufacturing, like automotive and stuff like that, industrial automation, robotics, a lot of it is still C, C++. Not C, C++, it's actually C++. But people in Google even, and I mean, there are enough evidence that there are people moving to Rust from C++ because Rust is just less buggier, more memory safe, this kind of thing. So it is a good choice. But at the same time, it is a verbose language. It has a little bit of a learning curve. Once you learn it, it certainly is a more intuitive paradigm. But it's not for everyone, right? Like, I mean, most people who write Python and stuff like that, they complain a lot about learning Rust. And I have written in my entire career C, C Sharp, ASP.NET, Java, Python, and I'm working at a company now which is all Rust based. I'm not a Rust expert by any means. I do write some, but I would say that I have not met a Rust engineer that is not that is not very good, right? So once you learn the language, it's actually good for you, but at the same time it's not for everyone, and not all the jobs that are around are that. So like it would depend on what you want to do. If you're doing systems infrastructure, by all means go for it, right? And in our case, we are trying to abstract it and give you a SQL interface or a Python interface, because that's what people are used to, and we can like hide the underlying Rust and stuff like that. We would not write our system in any other language if given a choice. But that's what it is. Okay, hope that answers your question, Kanish. Does that answer your question? Okay, excellent. All right, well, videos organizers will deal with. Thank you so much again. I am going to go get some rest for the night, and we are going to see each other again when the hackathon starts, and all the very best.
Thank you so much, Dave.
All right, cheers. Good night. Bye.
Good night.
Before
Bye.
we conclude, I want to leave you with a thought. Innovation thrives in a space where ideas are shared, challenged, and refined. Use this platform to not only gain knowledge, but to create something impactful. Every interaction, every discussion, and every challenge you overcome here brings you one step closer to make a difference. The future is shaped by those who dare to push beyond limits, and I believe that each one of you have the potential to drive meaningful change. Thank you for being a part of this 6 hour long bootcamp. We hope you gained valuable insights and now ready to build something incredible using Fluvio. Your participation has already given you an edge in the InfinyOn track, and we can't wait to see how you apply your knowledge. Wishing you all the best for the hackathon. We are excited to see some truly innovative and exciting projects from you. Don't forget to share your thoughts about this bootcamp on your socials with hashtag HackHazards25. Let's keep the momentum going, keep building, keep innovating, and make an impact.